Now, I would like to discuss database modeling for a big music marketplace. We're going to talk about the website that is called discogs.com. Here it is on the screen. It's basically one of the largest databases of music, of physical media, that is CDs, vinyl, cassettes, and so on and so on, with hundreds of thousands, I think, artists and albums and probably million releases and so on. We're going to build first the logical model according to the approach that I present in the database design book. We will build a catalog of three things: anchors, attributes, and links. We will initially we will not talk about the physical schema, the tables, indexes, query optimization, and so on. We will just talk about the business of selling physical music and how to prepare it for implementation if we would be building a clone of Discogs, for example. So let's take a look at discogs.com. Let's take an old, well-known artist such as Pink Floyd. They have many releases, 314 releases at the time, and lots of versions of those releases, and so on and so on. There is a lot of detail here, but I'm going to show how to treat those details incrementally so that you can basically work in really small pieces and design the basic functionality and then add more and more of detail if you need. Discogs has a huge catalog of music, basically content catalog. Here are the releases. Here is the list of tracks. Then Discogs has a sort of social network, that is, users can say that they have this album and they also want this album. They can leave some ratings and leave reviews and so on. Here is an example. 100,000 people have that specific album. The third interesting part of this is that you can sell music and you can buy music. So here, for example, for this release, there are 2,600 listings, and you can see that they are all over the world and all sorts of formats, item quality, and so on. So we'll start with the simplest, with the most simple part of the database schema, of logical schema, that is. So what we have here? First thing that we have is, of course, artists. You can look at the URL and you can see that it says discogs.com/artist/numeric ID -Pink Floyd. Looking at URLs is sometimes useful, and thinking about URLs is often useful when you talk about database design. So we have a name, we have some photo, but there are probably many different photos, of course. There are sites that basically refer to this band, list of members, some of them crossed out. There are variations of name. Now let's look at the list of releases. So here we have format, labels, country, and the year. Let's look at. So the first thing that we want to do is to take a sort of overview of what is available and what sort of variation we can expect to find. Of format. So we have album, we have vinyl, LP, CD, cassette, we have reissue, remastered, and so on and so on. Let's see what all of that means later. Then we have labels. EMI, Columbia, and so on and so on. Country. US, UK, Europe. Europe is also a country. And if you scroll a bit lower, you can see that there are also sometimes Australia and New Zealand, so several, Singapore and Malaysia, so several countries can be a country. Let's find out how to model this. Year is very easy. It's just a list of years. Cool. Now let's take one album and see what we have here. So we have cover photo, also many different photos. We have the name of the album, A Saucer Full of Secrets. We have track list. We have some credits. Credits are going to be complicated because this is music, but we'll talk about that later. The first video is going to be like 30 minutes. We have a lot of notes, we have some formats as before, and we have other versions of the same thing. No, this was, so again, let's look at the URL. You see that here we have a discogs.com/release/ID Pink Floyd, A Saucer Full of Secrets. And we can see here that this is vinyl, LP, stereo. It was published by a certain label, and it has a SKU, I don't remember what it's called. There is a series, country, when it was released, genre, style, and so on. We have a track list, and we have some credits for the tracks. We have companies. We have other versions of that. You can see that this one is in Canada, and another one is in France, and so on and so on. There are also some recommendations, which is also interesting. And there are some reviews or comments left by users, right? We can also see here that you can shop three of those three items of those of that particular vinyl. You can see some history that it was sold for as low as 11 euro and as high as 150, and so on. We can add it to our collection. There are some videos, blah, 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 blah. So this is the release. And the previous thing it's called a master. If we look at the URL, it has a different ID. So we have one, what is called master, that has several releases that were published across the years. Basically, we know that because starting from 34 releases in 68, 16 in 94, and so on and so on. So basically, every year some release of this master comes out, right? So we can already begin start building our logical schema, even though we see that there is a lot of complicated details. So I have these Google Docs with some tables that we are going to fill across along those series. So first thing that we have is a band, and band is a typical anchor, of course, or entity, if you want, because there are many bands. New bands can be created, and so on. So let's have band. ID example. Here we have just an integer ID. Very often IDs are not really interesting, but sometimes they do get interesting. And table name, we will not be talking, as I said, we will not be talking about database tables right away, much later in this in those series. So we skip this column. What the next, as we remember, is an album. Again, ID is not very interesting, and in the URL, they call it master, and maybe it makes sense for them. We will start with using the word album, and then we'll see if this name will continue to be useful. Because often in database design, you start using one name, and then at some point you realize that this name was unfortunate. We will see why, or maybe not. Now let's add some attributes. So we have a band, and the first attribute of the band is, of course, its name. So we document the attributes using questions. So the question about band name is going to be, what is the name of this band? Name is a string of text, and we will put it as the logical data type here. Example value. Let's use think for it. Physical column and physical type. Again, we won't be talking about that right now. What else can we add about the band? Actually, we can skip almost everything here. For now, it's enough to have just the name. And for the album, we also have a name. So let's add another attribute. What is the name of this album? It's also string, and we add an example value of this here. Now we need to talk about links. So bands can have many albums. That's obvious. Links are also called relationships in the classical as a classical term, but we will use the word links, and the link connects to anchors. So here we have band and album. Cardinality. Before we talk about cardinality, let's enter the sentences. So band has several albums. This is the first sentence, and the second sentence in the other way around. An album was created by a band. A band has several albums. An album was created by only one band. What we have here? We have semi-formalized sentences that are almost readable. Well, I mean readable, but they also have a very definite structure. They mention two names of anchors, and they have to they have to mention one of two words, several or only one. Yeah, it makes sense. A band obviously can have several albums, and one album was obviously created by only one band. This is music. Maybe it can get more complicated, but we will talk about that later. We can handle the most common case here, and then we will see how this logical model gets extended as we get to more complicated cases. So what is the cardinality here? It's 1 to n. One band, several albums. Again, the last column of this table is tabular column names, and we are skipping that. Nice. Next. So this is an album, and this is a master release. We see that here. Now we can look at the releases of this master of this album. So let's take one of the earliest releases. Again, looking at URL, we can see /release/another ID. Here we see that there is a lot more information, like a label, format, country, when released, genre, and so on. So let's record all of this. So first we have a release. Now let's add some information about releases. So the name is the same as in album. So release inherits that from that. Let's talk about labels a bit later. The formats are list of list, like comma separated list, several values. So it cannot be an attribute because an attribute is a single value. What we country is UK, but country is going to be a separate anchor. It's not an attribute again. Sorry, I'm kind of getting a bit ahead of myself. One thing that we can see is like a definite attribute is release day, June 29, 1968. So when was this release released? And the data type of this is date. And an example is 1968 06 29. Nice. Again, those sentences are sort of readable, but sometimes or very often they sound awkward. My English is not my native language, but I'm not even sure if it's possible to write more less awkward sentences while they are precise enough so that you can use them for database design to build the logical model that can be later converted into tables into the database that you're going to use from your application, query, insert data, and so on. What's next? Let's go back to labels, right? So we have a Columbia. Oh, let's click on Columbia and see what it means, and see what's in the URL. We have /label/ID dash Columbia. Columbia Records is the oldest brand name in recorded sound. That's a profile, parent label, sub-labels, contact info, some links, and here is the list of releases. You can see that there are 250,000 releases were published by Columbia. Nice. You can also see reviews of, I don't know what, maybe it's reviews of albums that let's find that out later. So it looks like label is also an anchor because of course there are many labels, they can be counted and you can create one, right? What are the label attributes? Name. What is the name of this label? It's also string and it's also Columbian. So you will have many simple attributes like this. I mean, like conceptually simple. Like what are we doing here, right? In this video, it's all pretty much pretty easy. Like everything has a name, but we make a point of carefully entering all the simple stuff because this would help us when we will actually reach for more complicated stuff. And we will reach more complicated stuff very quickly because this is music and it's gonna be fun. So why we wanted the label? Because we wanted to make a link between this release and the label. So, right, I forgot. We also need to enter the link between album and release. So an album can have several releases. A release belongs to only one album. So because we have again several and only one, we can see that the cardinality is 1 to n. Cardinality is one of the, I think it's the most important piece of element of data, because it's the hardest to fix when you get it wrong. And that's why we write out those sentences, because we want to read them aloud, and we want other people to read them and see that those sentences either make sense or don't make sense from the point of view of business, how it actually happens in reality, right? And that's why we already sort of like you can imagine an album that was created by several bands, right? There were lots of collaborations between people, right? How we're gonna like how are we gonna handle that? So it's possible that very quickly we will find some album and we will have to fix this logical schema, right? But the cool thing is, of course, that it's super easy to edit this document, right? We haven't started coding anything yet, so we have larger chance of making it right if we start from thinking about our logical schema. So let's leave it like this. Let's add a link between release and a label. So we have a label and we have a release. A label can publish several releases. A release can be published by only one label. Again, so the convention here is that if the cardinality is 1 to n, then the one-side anchor goes first. Nice. Let's hide credits just so that it's going to be easier. We will start talking about track list later in the following video. That's it for now. Thank you for listening. We will continue talking about the content catalog in the following video, or maybe several. Then we will talk about social network aspect, like users and what they can do with the albums here, like collection, reviews, and so on. And then we will talk about the like a commercial part, the selling and buying of music. So what we have so far, we have 4 anchors, 4 simple attributes, 3 links. We will, like, my wild guess is that if we theoretically process the entire functionality of Discogs, and it's quite complicated. There are many non-obvious things that are happening here. I'm a long time user, 20 years something, and interesting stuff could be found there. I mean, in terms of how much information is stored there. So my wild guess would be probably less than 100 anchors, but some of those anchors are going to be super, like, I don't know, weird. For attributes, twice as much, and for links, maybe about something like that. Also like 100 or something. We will see how this prediction is going to play out as we continue with those series. Cool. So thank you for listening, for watching. Here is my database design book that explains this approach to designing databases in detail. See you on the next one.